situations in which it could not otherwise handle. Like if you're writing to a file and somebody ejects the flash drive, or your hard disk runs out of space, or you're attaching to the internet and the internet connection goes down, things like that. Any of that stuff could cause the program to halt. And you've seen the classic Windows error, Program has performed an illegal instruction and will be shut down. That typically means that that thing has not been properly implemented with exception handling. So when a Microsoft application does that, it's infuriating. So something unexpected has happened or been detected. So the program should be able to deal with the problem, right? If there's a problem, it should just die. Your browser program should not just, die because it lost its internet connection momentarily. Your FTP client should not die because the server that it was communicating does not exist, stuff like that. And so you could have simple exception handling, complex exception handling. You can use it for your own purposes. You can make your own exceptions so that if you're making a library and it gets into a state where it could not recover from, it could generate the exception. And the person who uses your library, uses your classes, would need to handle that. So the terminology, the exception is the problem. It's the thing that signals an error. I mean, of course, it's not the error itself, but the error happens, and then the exception is so-called thrown. Thrown the exception. It sends a signal that the error has occurred. And so if an exception occurs and it's caught in the function that in which it occurs, great. The function can keep running as normal. If it does not, then the exception will be propagated back up to the code that called that function. And if that one doesn't handle it, it'll be propagated back to the code that called that function. And if that function was main and main doesn't handle it, then the operating system kills your program. So that's throwing an exception. The exception gets thrown. And then catch. In other words, handling the exception. Divide by zero occurred, you catch the exception. Now we'll see it doesn't actually throw an exception when you hit divide by zero, unlike Java. So the keywords, throw, followed by an argument, used to throw an exception. Some people call it raise. I raise an exception. Try. Try is the block that gets called when the exception occurs. No, excuse me. Try is the block that surrounds where the exception can occur. But the syntax is try, and then you have some line of code that could fail. And then you have a catch. And it's like an if statement. If error, then execute this code. Catch, and then if an error occurs, it goes ahead and executes that code. Otherwise, it skips the catch block and nothing happens. So the flow of control. If there's a try block and an exception is generated within it, okay, then the function terminates at that point, and the try block is immediately exited. I'm not liking the fact the function terminates. It doesn't terminate the function, but it does immediately exit the try block. Kind of like if you have a break. I guess you could say the break was, the loop was terminated. Anyways, code execution is transferred immediately to the catch block that matches the try block. If a catch block is found that matches the exception thrown, it is executed. If not, then the program terminates. Because there's all sorts of different exceptions. A file not found exception is quite different than, a socket failure connection from trying to access the internet. And your program needs to be able to distinguish between the two. So an example. Here's we are throwing our own exception here. This is a function that throws an exception. Int total days. If the days is less than 0 or the days is greater than 7, it blows up. Else return 7 times the number of weeks plus the number of days. And we could also make it blow up if the number of weeks was less than 0, right? Because that's an invalid value. Yeah, let's implement that. X or Y. And there's all my boilerplate. I'm going to write a program called calc pounds, or how about convert from, yeah, calc pounds, because you can't have a negative weight. That's going to be our rule. So double calc pounds, or calc LB here, calc underscore LB, and its input is kilograms. We're going to check to see if kilograms is less than 0. And if it is, we're going to throw an error. And that's pretty aggressive, because that means that the code that's calling will need some exception handling, or else it'll kill the program right then and there. So you don't just use throw for run-of-the-mill problems, right? You use it when stuff is serious and where the program absolutely could not continue.
Throw is an actual keyword, bro?
Yep, yep.
Oh, I thought it was just like a...
Nope, not colloquial. It is the actual keyword. Yep. So if kg is less than 0, we're going to throw. Throw quote kg must be, or cannot be negative. Else return kg times 2.2. I know that that's not the exact formula for kilograms to pounds, but close. All right, now we're going to ask the user for the number of kilograms, and then we're going to see what happens. So double kg, cout, how many kg, backslash n, cin into kg, now let's call calclab. So double lb, I think I'm going to declare that up here, double kg comma lb. It's just sort of nagging at me that maybe I ought to declare it that way. That's why I made the change. If I come up why I think that, I'll explain it in a little bit. LB is equal to calc LB, passing in kg, and then let's print it out. Cout, arrow, arrow, LB S equals space end quote, arrow, arrow, LB, arrow, arrow, ENDL. So if we type in a non-negative value, it should print out the pounds. If we type in a negative value, the program is going to terminate. How many kg? I don't know, 100 pounds. Pounds is equal to 220. All well and good. How about how many kilograms? Bless you. Negative 100. And it blew up. Unhandled exception. Now what are we going to do? Are we going to break? Or are we going to continue? Well, let's see what happens if we hit continue, just out of my curiosity. Pounds is equal to negative 1 pounds on 90. All right, that's pretty pathetic looking. I'm going to run it again and click break. Negative 100 pounds, break. This is the next statement to execute when the thread returns from the current function. So if we hit the continue button, it would run the else, and it would return our invalid value. Now, honestly, I don't know why it didn't just return. You know, we passed in 100. At this point, kg should equal negative 100. When we return it, okay, I'm going to hit the next thing. I'm going to go up to debug and do step over, which means step to the next line. Yeah, alrighty. I'm going to give up on that, and I'm going to stop the debugging. All right, what do we got to do to handle this? We need a catch. So what we're going to do is we're going to put a try around the code that can blow up. And is this the only way to handle errors? No, we could check the value, right, before we even call the function. But sometimes you can't check in advance whether something's going to fail. You don't know whether a hard drive is going to run out of space during the middle of a write. So there's our try. Now we got a compilation error because we don't have an associated catch. Wrong. Okay, fine. Don't go away, Mr. Window. So when we call our code, we need a catch. And what is it going to catch? It's going to catch a string. Now you Java folks probably will spot that this is a lot more primitive than the Java exception handling situation, where an exception was an object and there were different objects defined for different kinds of exceptions. You could kind of simulate that with this, but by default that's what it's going to catch. It's going to catch a message. The message that was thrown was in the form of a string between quotes. Now we've been calling those strings, but what that really is a character array. And I've said that arrays are pointers. What it really is a pointer to a character. So that's why they have this. So down here, we're going to do catch, parentheses, char star exception. And we can print the exception because it's a character array. And CIT takes that as well as anything else. Now when I run it and I type in a positive value, it's going to work. Cool. Now when I run it and type in a negative value, kilogram could not be negative. Now like I said, this is kind of a spurious example. You would not use exception handling for such a simple thing. And I guess you could. But it made it more complex, right, than if we had just put if kg less than 0 print an error message. So what could we do? We could put this in a loop. And we could break if we get some good data. So that's what I'm going to do. Before the try, I'm going to put a while true. And then I'm going to put a break after the cout, or after this line. Actually, I need to rearrange this just a little bit before I make it a loop. Take that cout statement, cut it, and move it after the catch. And here, after the double kg stuff, let's put while true. Has to be in quote, parentheses, while true, end parentheses, curly brace. Get rid of that close brace. Tab everything over all the way down to the catch statement, like that, and put a closing brace there. We're going to have to do a little bit more because since it's a while true, it would never break. We're going to put a break after the LB calculation. But if we get an error, we need to tell them what they need to do to fix. So we're going to print out the exception, or we could even print out just something like this. Value must be greater than or equal to 0. Please re-enter. Something like that. So the way this is going to work, and this is a common way of setting up these things, not just for, calling something in the catching of an exception you wrote, but any exception handling. You declare your variables that you care about before the loop, because you want those variables to exist after the loop. So that's why I moved that LB creation up there. Then, okay, try this over and over and over. How many kilograms? Get the input. Try our risky calculation. If it doesn't blow up, it hits the break statement, it exits the loop, so it can come down here and print the answer, which I don't see here, so I'm going to put that there. I'm also going to move that there. I'm also going to move that there so I have more stuff on the screen at the same time. All right. So if this does not throw an exception, execution continues, hits the break, jumps to the end while, and prints out our answer. But if an exception does occur, if this blows up, it skips the break statement, it comes to the catch, it prints value must be greater than or equal, please re-enter, and so the loop repeats and it asks again. So this loop is not going to allow ourselves to exit until they enter good data. We'd have to put a little bit more logic in if we wanted to give them the option to quit, right? Type in -99999 to quit or something like that. We could do that, but we're not going to muddy this up with too much logic. All right, so type in a -100. Value must be greater than or equal to 0. Oh, yeah? 0. And 0 kilograms is equal to 0 pounds. Very good. You saw that it ran once. It asked the question, twice. If I kept entering negative data, it would have continued to prompt me until I finally got bored with teasing it and entered positive data. That's exception handling in a nutshell.
Can you go to the function double?
Yeah, sure. That one?
Yeah.
Okay. Let me come look. Okay, so if you're using a version of Visual Studio that's different than mine, it might not be working. And the problem is that the throw here and the catch here are not the same thing. They look the same, but apparently in later versions of C++, just because you put quotes around something doesn't make it a character pointer. We're going to force it to be a character pointer. We're going to do this. Honestly, I don't know what it's returning. I'd be curious to find out. But that will fix the problem. Curious if it will for you.
And then we can catch a care.
Right. And then down here, when I was wandering around trying to help, at one time we played with catching an int instead. And you could do that. And each int, if each different value of an int means something else. Right, you could set up an enum, which was an error list, and you could throw, one of those enumerated values. Now I've talked a big game. Let me make sure it works. Works on mine. Good deal. Hopefully it works on yours as well.
So, can I,
Let me come look.
yeah.
Or what do I need to scroll to?
No, yeah, that's what I changed, and I still didn't get to work. Oh, wait. Care star exception, right? In the account.
Yeah. And so that catch now matches what we're throwing. Precisely.
Okay, it worked.
Good deal. All right. Sorry about that, gang. So what I was talking about as an alternate solution with the recording pause is you could create some enum or some, # define error 1 is an int, -10. I probably wouldn't even need that, so I'm going to take that out. And then # define error 2, is equal to -20 or whatever. And then you could throw one of those guys. And then we could catch ints. And then we could switch our behavior or do if, based on what kind of int we caught. It's a possibility. And down here, I could change that to, catch an int. And then if, the int was a 10, or was one of our errors, do something important, right? Because that's the error that it threw. And that would have fixed the problem as well. That's one of the things that we played with. So you could make an exhaustive list of all the different error values. And if you did that, you could enumerate them. You could make an enum and match those. You wouldn't necessarily start with 10, 20, and 30, right? But, pardon me?
As opposed to looking for a negative number, you would look for the actual...
They didn't have to be negative numbers. I just made them up.
Yeah, so, but right there, like, you would be expecting that number to show up, right? -10. If that's the way you're using it.
Right. If I throw an error 2, then the catch's parameter is going to equal -20.
Right.
Yeah. Hope I answered your question.
Yeah, no, that's
Okay. Okay. Oops. Wrong. Now, I'm going to show you something that doesn't exist in this language, but it exists in a lot of others. So I'm going to mention it and then flush it from your brain, except for the Java students. Some languages have a finally. Uh-oh, it's been added to C++. Cute. It's a keyword, but it doesn't compile. So anyways, what finally is supposed to do is this is code that's going to run regardless of whether this code succeeds or fails. Down to the point where even before the break happens, or as the break is happening, it would run down here and print that. Or if we had a return statement here after our failure, if we were going to return 0 out of our function or something, when it hit the return 0, it will come down here and execute this first. Why? Because maybe you had some files open up at the top, and then you had a try and you had a catch, and if the catch needs to fail out of the function, so you put a return statement, you might have 20 different catch blocks. You wouldn't necessarily want to put close file, on each and every catch block. Instead, you could just add a finally block. Well, too bad. We got to do the other thing, right? It doesn't work in C++. Just want to tuck it away in your head, so if you do see the keyword finally in one of the languages that supports it, that's what it's doing. That means that the code that this book is demonstrating would not work, because they caught a character string just like we did. So let's give this example. We're going to declare 2 ints, and we're going to try to divide by 0 and see if that does a try catch. See if it triggers it accurately. So down here, try int x equals 1, y is equal to 0. Int z is equal to x divided by y. C out x divided by y equals space end quote But I'm going to try that without the benefit of a try first, just to see if it actually generates an exception. Something convinced me that C didn't die if you did divide by 0. But now that I'm thinking about it, I think that's if you're doing doubles. It's okay to divide a double by 0, but not an int. That could be the case. Nope. Or yeah, it fails if you divide by 0. Throws an exception. Okay, cool enough. Hit break, stop our debugging. What if these were doubles? That was my theory, is that you can, or that's my new theory, is that you can divide by 0 if they are doubles, but not ints. Yep, you get this silly answer. 1 divided by infinity, or 1 pound infinity. Okay. I'm going to change those back to ints. And I'm going to make it a try-catch block because I don't want our code to fail when that happens. So catch, and the slide says that we can go ahead and catch a char star exception. Let's just print out the exception that's thrown. Cout error error ex error error endl. Maybe we'll say exception caught colon space end quote error error ex error error endl. And I forgot my error error at the beginning of this. All right, now it's good. And it hung. Not what I was expecting. Isn't that interesting? What if I compile it for release rather than oh, are you really going to make... Okay, it did generate an exception. Unhandled exception. Enter division by 0. And it doesn't say what exception was thrown. Did it work for any of y'all? Did any of y'all type it in and actually get... Did it hang for you? Did it generate an exception? What happened? Everybody's got their hands on your keyboard. I know you typed it in. Did it run or not?
Mine did not.
Okay. Did not catch it, in other words. Yeah.
Yeah, mine did either.
All right. Did I misread the slide? Oh. They wrote a function called divide. Right? Is that how they did that? Yep, divide. If the denominator is equal to 0, they throw it. Same business. I wonder what happens if we put a throw right here. Like if we do this. If y equals 0, throw, and we know we need to do that char star business. So throw, parentheses, char star, in parentheses, quote, cannot divide by 0. Well, I didn't get an error message. I mean, I didn't get a, the exception handler didn't kick in, but it sure did close the window fast. First chance exception handler. Well, I'm having problems getting that to work. I'm going to delete that line, and I'm just going to write another function just like we did. The function int z is equal to div x comma y, end quote, and I'm going to go and divide, create a function called div. No, div I better replace it with something else. Div is apparently a built-in function. So divide, just like the book demonstrates. Now I'm going to go and define a function called divide. Scroll up here, double space, divide int x comma int y. If y is equal to 0, throw char star end parentheses division by 0 error. Else return double parentheses x. We're casting it to an x so that it won't do integer division and round down. I mean, we're casting it to a double so it won't do integer division and round down, divided by y. Not sure, hope this works. We're going to skip this topic. There, it caught the exception. I'm so happy. I guess I should have typed in exactly their code. I'm surprised that divide by 0 that we were not able to catch that exception directly. We ought to be able to do that, so I'm going to Google it. We should not have had to write our own divide function in order to catch the division by 0. Because if we were going to go to the trouble of writing our own code and check if something is equal to 0, then we could have done that before we did the function, right? We could have just done if. Check that out. C++, catch divide by 0. You need to check it itself and throw an exception. Integer divide by 0 is not an exception in standard C++. Apparently it is in Microsoft, but not in standard C++, and since not all of us are using Windows. So here are the exceptions that are built in to C++. Domain error, invalid argument, length error, out of range, runtime error, range error, overflow, and underflow. So, Stack Overflow demonstrates doing the exact same thing that we did. Except they cast the error. They created their own, they created an exception object by doing std : overflow error. And so their catch looks like this. This is demonstrating that you can catch more than one kind of error. Let's see how many other errors we can spot. Well, we saw some when we were looking at that list. That's cool enough that I'd like to go ahead and implement our code to do that. Why overflow? Because it's infinity if you divide by 0, right? So, we're going to do, we shouldn't need to do std : because we're already using std. So, overflow, I'm in our divide function again. Overflow underscore error, parentheses, quote, division by 0, like that. Then I'm going to go down, and I'm going to, my catch is going to say catch overflow error. Make sure I get the syntax exactly right. All right. So I'm going to come down here, and where I was catching, right there, this is after my divide by 0. Where I was catching char star ex, I'm going to catch overflow underscore error, space e or ex, and the exception that I'm going to catch is I want to get that message out of it, so I'm going to call ex.what. Parentheses in parentheses. What that does is it returns the string that was stuffed inside the exception object. All right, I like that. I feel good about that. That's not how the book shows it, but it feels more like real-world programming to use an exception object rather than just generate a string. Now, ultimately, right, it turns it into a string at the end of the process anyways. But I got so used to Java programming where you had a million different exception object types that were created that this feels better to me.
So overflow error is something that's in C++.
It is one of the standard exceptions defined in C++. And you're free to use it if you want, like logic error. We could call it a logic error. Out of range, right? If we detect that our array, we're going to access past the end of the array, we might want to throw an out of range, and we might have catch the fact that it was out of range. So we're kind of making up for lack of safety features in the C++ language if we implement good exception handling.
That comes from the STD, like the library. Where does it come from? Is it just
Well, let's find out. Let's click on overflow error and go to source, see where it's generated. Go to definition or declaration, one of those two. All right, there's a file called std except, standard exceptions. And apparently that's brought in by default every time you compile. We did not do #include std exceptions, but we did do using namespace std. That's Java, sorry. So if we had left that out, then we would have to do throw std : But if we had left that out, then we would have had to put all that on all the couts and then. All right, did I break anybody's code? Anybody need eyeballs on the screen? We all good? All right. What if no exception is thrown? Then the catch isn't triggered, right? It just falls to the next statement outside of cout. Just like it was an if statement, right? And if the if condition was false, it just doesn't do anything inside the block and it goes to the next statement after the if. Or after the, the closing brace after the if. So there are predefined functions such as new may throw exceptions. The value that is thrown does not need to be used in a catch block. In this case, no name is needed in the catch parameter definition. And we haven't talked about new, but let's see if they give us an example of that. So the catch block parameter definition does need the type of exception being caught. Well, that's kind of dumb. They're just saying give it an exception, but don't give it a name. So we could go in here, and if we did not actually want to use that object, that would compile just as well. Okay. Nice to know. I don't mean that sarcastically. I'd kind of forgotten that in the catch thing you could just list the type without giving it a variable in order to hold that. So the exception class can be defined in a class and thrown as an exception by a member function. So an exception class might have no members, in which case it's only used to signal an error, or it might have other members, which is data to pass to the catch block. So if you have a complex class and you need to be throwing all sorts of different exceptions out of it, then you would define an exception class as part of your complex class, and you would define all of the different types of exceptions that can be generated. So for example, here's a rectangle class, and it's got a width and a height. Now we're going to make an exception class. So class, negative size. Doesn't have the word exception in it. It's just a class. We gave it a cute name, negative size. And down in our code, Why didn't I see where it got thrown? Oh, because they didn't put the methods in line in the header file. Remember how I showed you could put the methods inside the class definition? Which they've done for some of these. Get width is defined right there inside the header file, and so is get length. But well, for some reason we're going to hide some other ones. Set width. If there's a problem with set width, it calls throw negative size. Parentheses in parentheses. So it constructs an object of that type and throws it. And so the calling code is going to have to catch it. And so the catch statement is going to look like this. It's going to be preceded by the name of the class that exception was in, colon, and then followed by the name of the exception that was declared within the class. Nested try blocks. Yeah, you can do that. You can nest a try within a try if you need to catch an error before something else happens, but you need to have a lot of different code that's being executed. Yes, you can catch. You can nest your try and your catch blocks. So one thing you can do is within your catch, you can do a throw, which says, I give up. So that gets passed up to the calling function to the driver that generated, or that called this function. Let me see if I can give an example. I'm just going to type this in because I'm not going to actually try to take the time to get it to work. Void foo. If error, then throw, a 1. And then void foo2. We call foo, but we're going to put it in a try block. Try this stuff. Foo. Was there an error? Yeah, there was an error, so I'm just going to throw it. Like that. Then down here, down in main, int or whatever, you call foo2. If you don't put exception handling in it, then it's going to stop your program when that error is generated. So you would put that in a try block. Whatever. And what if there was some other business inside here that was so dangerous that we needed it handled differently, like that? You could put some code in here, blah, 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 blah. And then, catch that. Whatever. And maybe this would all be in some kind of while loop, right? While true, do all this stuff, and then if that works, then break out of the while loop. Otherwise, don't. So what's going to happen? We go into try. We call foo. If an exception happens and we do something and it loops again, eventually it's going to work. So it will break, and we would break out of that code. But then if there was something else that could generate an exception, like right here, and I'm sorry, I've done this a little bit wrong. That should have been while true like that, and then the call to foo should have been in there. Like that. We have nested tries at this point. This try would need to handle whatever kind of problem it can do. And then we'd have an outer one. So just like any other programming structures, you can put if statements inside of if statements inside of while inside of ifs, tries inside of ifs inside of tries inside of tries. Alrighty, we are at the end of what I wanted to talk about today. Anybody have a problem with getting out 20 minutes early? How about you two? Nope, you're shaking your head. No, you don't have a problem getting out. Are we all good? We all good ending? I could find something else to lecture about, but I think we're good.
At one point, like, I know you weren't going to give a final, and I'm not asking for a final, but I was just wondering if there's like a review of the class we could do or something, like, just like some things that I don't feel like 100% on.
Yeah, I would be glad to do that. Like if you come in on Tuesday and ask some questions, I'll be glad to lecture on those things. Now we got farther than the other classes got, so I don't have review material set up for the things that we've done since the final. But I could happily lecture about them or lecture about any other topic.
Okay, cool. Yeah, that's just a couple things I want to go over again.
Yeah, that'd be totally cool. And I had the people in the Java class ask for that. They wanted a rehash, a reiteration of object-oriented programming from top down, and I was happy to do that.
Cool. Yeah, because like functions and pointers and references are
they're a bit abstract. Happy to talk about them.
Right now.
Exactly.
Yeah. Okay.
Yep. Totally get you getting stuck on those. Absolutely. All right, let's make a Dropbox and be done.
So I think there was one final quiz that, I don't know if you ever signed it up, but on my end it's showing that it's still open. So do you want us to go ahead and clean up any things like that that are still outstanding?
Let's see. Huh. I'll make it optional. I want you to do it. You get extra credit that gets added to all your other quiz grades. But it's not going to be on an exam. I shouldn't even make it optional. I would like for y'all to do it. If you don't, it's not going to hurt you. Maybe we'll do one of those things where we do it in class on Tuesday.
So Tuesday's the last class for all classes, correct?
Yes, Monday or Tuesday is the last day for all classes. And then Wednesday and Thursday are finals. And then some people have finals the following week. All right, so yeah, what is a class? Yeah, this is a short quiz. Go ahead and take a look at it, and then we'll cover it in class on Tuesday along with the questions that you have. Yeah, thank you for mentioning it. So it's Y.